Hello, hello, hello. Welcome to our first video of our journey through Algebra 1 this semester. And so this semester we'll be going through a bunch of units, and as I talked about in class, we'll be having this process of watching videos before you come to class, and in these videos you'll have the opportunity to learn about vocabulary, get some insight on what our lesson is going to look like, start to formulate some questions you have for me. So these are meant to really start to get you thinking about how to do the homework yourself, and when you come to class, how to ask questions for me. And so when you are looking at our first lesson here, we are starting Unit 2, and I know you wanted to start Unit 1 first, but we're starting from 2 this time. And so in Unit 2, we talk about how to model situations of real-world contexts. And so I know that's a bunch of information all at once, and so we'll break it down slowly, and we'll be talking about how to use equations, specifically linear equations in the beginning, to model our situations of our real world. And as you can see in the beginning here, we are looking at our main dishes and side dishes. We'll be looking at blueberries in the second one, and we'll be really moving forward through different scenarios throughout this unit. And so at the beginning, it's really just an exploration, an introduction. And so the goal here is to make mistakes and do your best on the homework, so when we go over it in class together, you have questions for me and things we can work on together. And so the newest thing when we're working in algebra is the idea of having numbers as part of our equations. And what you used to have before is you used to have things like working with things like 2 plus 2, you knew that equaled 4, and now you're doing multiplication as you're getting bigger and bigger, older and older, and then at some point you start working with fractions. And so now the question becomes, all right, an equation with letters, and what do those letters represent? And so our equation, right, this represents an equation. Our equation has some equal sign. We have an expression on one side, and we have an expression on the other side, set by some equal sign here in the beginning. And so those letters represent some value, right? So our letters here, right, we have M, S, N, and T, right? These represent our variables. Variables represent values, right? We don't necessarily know what values they represent now. They can represent multiple values when we start moving forward. They can represent one value or no values. And as we're moving forward, we'll see how these things develop. And so you'll start to create and interpret and reason about equations with letters that represent quantities, but we'll get there. And so this is just an exploration to introduce you to, okay, what is an equation and what does it look like with letters in it? And so here's a situation that we're looking at in the beginning that we're looking at some letters and what they represent, right? M represents the cost of a main dish, N represents the number of side dishes, S represents the cost of a side dish, and T represents the total cost of a meal. And so I've given you 3 equations here, and the question is, okay, what does each equation mean in this situation? And so that's when you want to connect all your dots together. The hardest part about working with our equations is understanding what the equation is actually saying. And from there, we can move forward. And so for the first one, when we're looking at our M equals 7.50, we want to look at, all right, what does M represent? M represents the cost of a main dish, right, as we see here. It represents the cost of a main dish. And so I know that if M represents the cost of the main dish and M equals 7.50, I know that a main dish costs $7.50. Main dish equals $7.50. Nice and cheap. And so you want to go through and think about, okay, let's look at the next one. What does M represent? What does S represent? And start to use those ideas and understandings, right? What does a plus sign mean? And these are things we'll be going over as we talk about it in class too, right? Does plus mean more of something or less of something? Are we talking about cost or are we talking about number of things, right? We saw cost here, but here represents number, but everything else here represents the cost. So pay very close attention to what the question is actually asking. And we'll be talking about this as we move forward. And so when it comes to the second activity, and all these activities slowly start to build on each other. And like I said, this first lesson is an exploration of equations. In the previous one, we gave you the equation and asked you to interpret. And now it's the opposite. So I give you a situation, blueberries, in the case of blueberries and how much they cost, and asking you to create an equation for them. And so, for instance, you are given the first scenario, blueberries cost $4.99 a pound. If Diego buys B blueberries, then how much he buys B blueberries, sorry, and pays $14.95. And so we can look at, all right, we're talking about blueberries, $4.99 per pound. And if he buys B pounds of it, and all of that equals $14.95, right? Slowly start to break up your equation. This is, and if you want, you can always start off using your words, right? Blueberries are, we have $4.99 per pound. We know that B is pounds of blueberries. And all of that ends up equaling $14.95. And so now you want to turn this into equation. We have a variable, we have our $4.99, and we know the total cost, the total amount that Diego pays is $14.95. And so how can you combine the 4.99 and the B pounds to equal your result? And I'll leave that up to you to get started with, and we'll be going over it together in class. And so then we start to generalize that, right? These all connect to each other. So how can you use each of these? Your original equation of $4.99 times the number of pounds equal to 14.95. So listen to my words as we're going through, and we'll start to understand how to represent all these equations. These are all exploration activities, and we want you to just start building on those understandings. And so we have this activity when it comes to blueberries and earnings. And now it transitions to representing earnings over working over the summer. I'm sure many of you may be working over the summer. I used to work over the summer too, and understanding how much you earn, maybe in comparison to others, or how much you earn in comparison to how much you earned last year. So these things should hopefully be slightly familiar as you're working through them. And so if Noah earns N dollars over the summer and May earns $275, which is 45 more dollars than Noah did, right? We're looking at our key words here. How do you represent more than in our equation, right? More or less, right? If I have more of something, is that addition or subtraction, right? If Noah earns N dollars and we have a total of 275, are we adding or subtracting? Our 45, right? What operation goes here? And think about how the wording of the equation. And this might be confusing, and that's okay. This is an introduction to our understanding of adding and subtracting and modeling our equations. And so as we move forward, we talk about modeling using equations, and we want you to compare them to each other. And then we start to look at how to model relationships of equations, right? We did it in words to equations, equations to words. Now we're looking at a table. So all of these things are just different representations of our idea of an equation. And so if we have a table of value, we have our two quantities. Look at our equation here. How can we look at our table here? Sorry. How is X and Y related? How can we find a relationship between both of them? Think about different operations you studied in middle school and elementary school. Think about adding, multiplying, subtracting, dividing. What can you look at here that will help us moving forward? And so as we take a look at this slide as you're exploring, and in the next slide, right, how to represent tables to words, right? We went from equations to words, words to equations, and now we're on to tables to words. Look at what the relationship is happening. What's happening here, right? If I take a look at table B, I see that we have a length of time meters from home, and we have meters from school. And so how do I write that relationship? What is the relationship going on here? If I'm 0 meters from home, I know that I am 400 meters away from school. So that's where I'm starting off with. And as I move closer, the further away I move from home, the closer I get to school. And so you'll slowly start to notice there's a relationship between each of these things. Right, I notice from 0 goes to 400. I also notice as I'm going through that 75 plus 325 is also 400. And so I know that there's something about 400 here that is important. And so I can say that, all right, the distance from home, which is my X, right, in meters, to the distance from home from home to school, right? School is represented by our Y, is 400 meters, I'm sorry. And so what happens as I go further from home, so I know that every meter traveled away from home is a meter closer to school. Right, and we can see that if I am at 75 meters away from home, then I am at 325 meters away from school. So one step closer, and you can think about this literally in a real world. If I take a step away from my house towards the school, I'm stepping closer and closer to school. And so it's the same understanding, and you want to use that in your development as you're creating your equations too, right? This is a table. Then I have my description, right? This is in words, and using all of that to create my equation. I know that my distance from home plus my distance of school is 400 meters. Every meter traveled away from home is closer to school. So I'm literally just taking a step forward. I'm just taking a step forward. I'm not bouncing like I'm multiplying. I'm not dividing by anything. Everything is just literally one step closer and closer. I have my distance from home plus my distance from school, which gives me 400. And you can check each step. Remember, you can always check your answer. And this is all exploration. 75 plus 325 is 400. 128 plus 272 is also 400. So as you're going through, and this definitely can seem overwhelming initially, you are just looking at each of the relationships of what an equation looks like and how we can represent it. And so you'll see that for the next few slides moving forward about sorting your cards together. If I have my cards here, these are my tables from the previous slide. How can I match them up? And I'm just doing this randomly. I wasn't looking. How can I match them up where I have the correct representation? And like I said, you can always check your answer, substitute in your values, and see what's happening. And so in the last one, now I gave you a situation. I want you to complete the table. And so you slowly want to build the connection between all of these relationships. And if you ever get stuck and you're watching the video or you don't want to go back and watch the whole video, the lesson summaries at the end are very, very helpful in explaining what this relationship is. So I always have them at the end if my computer keeps up with me. There we go. I always have them at the end as a way for you to summarize the information as well. I know that's a lot of stuff you hear in the video, and this video is especially long because it's the first one, but hopefully everything moving forward will be nice short videos to summarize what the information is. And if you have any questions, always feel free to reach out to me. If you're confused by anything, just send me an email, write it in your Decimals activity. I don't know how to do this. Let's go over it together. I will be here for you and we'll get this done together. So I look forward to our Algebra 1 journey, and I'll see you in our next video.